Hello friends, we have discussed about the efficiency of the worm gear, then the strength rating, wear rating of the worm gear, and also the thermal considerations in worm gear. So let us start solving the numerical. So we will start from basic how to calculate the different dimensions if the worm gear is designated, and then we will proceed for one numerical on force analysis, and then we will go for the numerical related to some based on thermal consideration and efficiency. In this way we will proceed. So numerical number one, a pair of worm gear is designated as 130 10 8. Calculate the center distance, the speed reduction, the dimensions of the worm, and the dimensions of the worm wheel. So if you discuss about this designation, so let me remind you the designation stands for Z1 Z2 QM. So I will write as given also, but for your understanding, Z1 Z2 QM. Z1 stands for the number of tarps. Z2 stands for the number of teeth on worm wheel. Q is the diameter quotient and M stands for the module. So this is nothing but the given. So I will write down what is given in this particular numerical. So I will say number of tarps on worm Z1, it is given as 1. Just refer what is given. Z2, it is 30. Number of teeth on worm wheel. Then Q, the diameter quotient, is 10. We have also discussed the relation between Q, D1 and M. And finally, the module is equal to 8 millimeters. So this is about friends Z1, Z2, QM. And let us start the center distance, the speed reduction. So one by one we will proceed for a calculation. So very first I will solution. So number one I will call it as the center distance. What is the formula for center distance? So A is equal to, we have discussed, 1/2 m into bracket q plus z2. This all the formulas which we are writing now, the speed reduction, the dimensions of the worm means the pitch circle diameter, or you can say the addendum and dedendum, or outer diameter and inner diameter for worm and worm wheel, or throat diameter, whatever. So these all the dimensions or the formulas we have discussed in the terminology. So I am just writing down the formula, then we will proceed further. So M, Q and J2, all the things are given. So I will just write 1/2 into 8 into Q value. The diameter quotient is given as 10 and Z2 is given as 30. So calculate the value. Very simple. 30 plus 10, 40. 8 by 2, 4. So 40 into 4. Very simple. You can calculate the answer as 160 millimeter. So you mention here itself center distance. Okay. So this is about point number one. So let us proceed for the second point. I will call it as point number two. The speed reduction I, again very simple. No any calculation is required in this case. So we are having the formula for I, nothing but Z2 by Z1. So very simple, 30 by 1. I will directly mention I is equal to 30. This is the answer for point number 2, that is speed reduction. So these are very simple pointers and it can be asked for objective type questions also. For example, center distance, if it is given, a pair of worm gear is designated as Z1, Z2, QM, whatever the numbers may be given, and you may ask to calculate the center distance and the speed reduction. Okay, so let us proceed further. Dimensions of the worm. So I will take on new page only here. So point number 3, I will say dimensions of the worm. So here we will calculate D1, we will calculate DA1, and we will calculate DF1. So very first starting with D1. So it is nothing but Q into M. The diametral quotient Q is equal to D1 by M. Therefore D1 is nothing but Q into M. So the value is given 10 into 8. So I will write down the D1. We can calculate PCD. D1 is equal to 80 millimeters. Very simple. Okay, then I will go for the outside diameter DA1. So DA1 M into bracket. I will write down here Q plus 2. This is the formula. So I will put. So I will mention here M value 8 into bracket 10 plus 2. So very simple. I will call DA1 as, or I will get answer 12 into 8, 96 millimeters. Okay. Now for further calculation of DF1, there is a formula for DF1 in which gamma is required. So I have to go for first calculation of gamma. So I will calculate very first. I will write down tan of gamma is equal to Z1 by Q, 1 by 10. So go for tan inverse and let me do the answer for gamma. So I am highlighting, we have calculated D1, we have calculated DA1. Like this I am highlighting. Now calculate gamma. This is tan inverse of 1 by 10. So 0.1, tan inverse of 0.1, 1 by 10 means. So what we answer we will get gamma. Then we can proceed for calculation of DF1. 5.71, very good. Any other? .71. Okay, then I will say DF1 is equal to M into bracket Q plus 2 minus 4.4 cos of gamma. So I can say 8 into bracket 10 plus 2 minus 4.4 cos of 5.71. So you will get answer df1 is equal to, and one more you can say px is equal to pi m is equal to 5 into 8. Therefore you will get px is equal to, calculate df1. df1 answer 60.97. Okay, very good. 60.97. We will say here, and this answer you will get it as 25.137 millimeters. So just to go for highlight. Okay, so these are the dimensions which we have calculated for worm. Now let us proceed for worm wheel. Okay, so last point in this numerical, we can say point number 4. Dimensions of worm wheel. Dimensions of worm wheel. So let us proceed for calculation for this worm wheel dimension. So you can say here now starting with again D2, DA2 and DF2. So friends, D2 is equal to M into Z2 is equal to 8 into 30. So you will get D2 is equal to 240 millimeter. Then DA2 is equal to, we are having the formula for DA2, M into bracket Z2 plus 4 cos gamma minus 2. So I will substitute 8 into bracket 30 plus 4 cos of 5.71 minus 2. So you will get answer DA2 is equal to, calculate the answer. Answer for DA2. Then we will proceed for DF2. 255.84. And last, M into bracket J2 minus 2 minus 0.4 cos of gamma. So you can say 8 into bracket 30 minus 2 minus 0.4 cos of 5.71. So Bf2 is equal to go for calculation 220.81. Very good. Millimeter. So this is the given, friends. A pair of worm gear is designated as, and then based on this basic only the designation is given as 130 10 8, and by using this Z1 Z2 QIM we have calculated the center distance, then this reduction in speed, then the dimensions of worm and dimensions of worm wheel. So these bits we have calculated. Now let us proceed for one more numerical based on this. So I will say numerical related to the force analysis. So we will discuss simple numerical. A pair of worm and worm wheel is designated as 360 10 6. So Z1 Z2 Q and M is given. The worm is transmitting 5 kilowatt power at 1440 rpm to the worm wheel. The coefficient of friction is 0.1 and the normal pressure angle is 20 degree. Coefficient of friction mu value is given and alpha value is given. Determine the components of gear tooth force acting on the worm and worm. So now let us write down given and proceed for the calculation. Given, so I will say Z1 number of torques 3, Z2 number of teeth on the worm wheel, then Q diameter quotient 10, M module is equal to 6 millimeter. Apart from this kilowatt 5, and NP, or I will say N1 1440 rpm. Then mu is given 0.1. Pressure angle is given 20 degree. What we have to calculate? We have to calculate the components of gear tooth force acting on the worm and worm wheel. Components of gear tooth force acting on worm and worm wheel. So let us start. We will calculate by first the basic things. Then we will calculate D1, then we will calculate gamma, then we will calculate kilowatt, then MT, and then we can proceed for PT, PA, and PR. For one means for worm, and then we will write down the components for gear. So let us start. So the pitch circle diameter D1 is equal to QM, or M into Q is equal to, I can say, 6 into 10. So you will write D1 is equal to 60 millimeters. Okay. Then gamma is not given and we require gamma for further calculation. So I will write down the equation for the tan of gamma. The tan of gamma is Z1 divided by Q, and let us substitute the values. So Z1 value 3, Q value 10. So 3 divided by 10. So 0.3. So you will get gamma is equal to tan inverse of. So this very first D1 value you have calculated. Then this gamma value we are calculating. What is gamma? 16.69. Okay, 16.7. No problem. Very good. Let us proceed further. So I will say the value as 16.69 or 7. Okay, we are having MT is equal to 60 into 10 raised to 6 kilowatt divided by 2 pi np or n1. So I can substitute the value 60 into 10 raised to 6 into kilowatt is given 5 divided by, I can say 2 pi into n1 1440 rpm. So you will get the value for mt is equal to, so this mt you require for substituting in the value of pt. So calculate mt, then we can calculate the pt, pa and pr, just a substitution of the values. 33157.27. Okay, very good. So I will say 33.157 into 10 raised to 3 Newton millimeter. Newton millimeter. Okay, let us calculate the first force. Let us calculate the first force. So we are calculating the components of gear tooth force acting on worm. This is very important. We are calculating now for worm. Okay, so I will write down P1T is equal to twice EMT by D1 is equal to 2 into 33.157 into 10 raised to 3 divided by D1 60. So I will get the tangential component acting on the worm as P1T is equal to. Answer for tangential component 1105.23. Okay, and very important, I am highlighting, we are calculating for worm. So 1105.23 Newton. We are calculating here the components of gear tooth for worm. First component calculated. Okay, now let us proceed for the actual component. P1 A is equal to, if you can write here, axial component acting on worm. P1A is equal to, the formula is P1T into cos alpha cos gamma minus mu sin gamma. I will mention this in bracket. divided by, we have discussed the formulas in the force analysis, cos alpha sin gamma plus mu cos of gamma. See, we are having the value of all alpha, gamma, and T also. So I will mention here what component we have calculated. 1105.23. So 1105.23 into, substitute the value cos alpha, cos 20, cos of 16.69 minus mu is given 0.1 into sin of 16.69 bracket complete divided by cos 20 sin 16.69 plus mu 0.1 into cos of 16.69. We will get the answer for axial component on the gear 2. Calculate axial component on worm 2633.81. Any other? 2633. Okay, so I will mention here your component 2633 Newton. 2633 Newton. Then I will go for, here we have mentioned the axial component, and very important, we are writing for worm only. So here I will write radial component on worm. So radial component acting on worm. So let us write down the formula. P1R is equal to P1T into all the formulas are converted into P1T sin of alpha divided by cos alpha sin gamma plus mu cos of gamma. To substitute the values, sin 20 divided by cos alpha cos 20 sin 16.69 plus 0.1 here into cos of 16.69. Okay, so you will get here value, the radial component. acting on worm. P1R is equal to any other answer for this? What is the answer for this P1R, the radial component? Hmm, 1033. Okay, so 0.77. Okay, so I will write. Now, if you refer, we have component the PT, P1T, P1A, and the radial component. Now, very important is to write down the components for so let us mention not required to calculate but very important components of gear tooth force acting on worm wheel. Just we have to summarize here. Components of gear tooth force acting on worm wheel. Acting on worm wheel. So now you can see here P2 tangential is equal to P1 axial. Now, what is the value of P1 axial? So I will say here 2633 Newton. Then I can say P2 axial is equal to P1 tangential. So you can say here 1105.23 Newton. And third one P2R is equal to P1R is equal to 1033.77 Newton. So this is very important step. The radial component is same for both worm and worm wheel, but as discussed in the force analysis, the tangential and the axial components are different as in the case of worm and worm wheel, and therefore it we have written here the tangential component of worm wheel will be equal to axial component of worm, and the axial component of worm wheel will be equal to tangential component of worm. So in this way, in the numerical, the worm and worm wheel designation given. So from that we have written Z1Q, Z1, Z2, Q and M, and then we have calculated the D1 which is required for further calculation in PT. Then we have calculated gamma, and starting we have calculated MT, the rated torque acting from the power, and then by using the formulas we have calculated the components of the gear tooth force acting on the worm. So very first we have calculated the P1T, and then we have calculated P1A, and then we have calculated P1R. So in this way, we have calculated the three components on the worm, and the components for worm will we have written from the force analysis basics, and only the radial component P1R is equal to P2R. Both the radial components are directed toward the center and they are equal and opposite or same. But P2T is equal to P1A, that is the tangential component for worm wheel is equal to axial component on worm, and the axial component on worm wheel is equal to tangential component of worm. So this is the numerical related to force analysis. So today we have solved two numericals, about one about the force analysis and one about the basic dimensions calculation.